Hello, I wanted to give you guys a review of the Chapter 6 lecture on proteins. So what is a protein? We talk about proteins a lot, and our body is made up of thousands of different kinds of proteins. Proteins make up about 17% of our body weight. The most unique thing about proteins is they actually contain the chemical component nitrogen. As we learned when we talked about fats, fats are long chains of carbons and they have hydrogens and oxygens on them, but proteins are the only components that contain nitrogen. So why do we need nitrogen and what is the main function of protein? There are many functions that protein provides, but the most important is that it supplies the body with nitrogen. And that nitrogen allows the body to build proteins in itself. The way that I kind of think about it is if you think about Legos. I have an 11-year-old son, so I always think about Legos since I step on them most of my day. But anyway, you buy a Star Wars ship and it comes with lots of different pieces. So those little different pieces are the amino acids. Those are the building blocks for the proteins. So you put together the Star Wars ship, and that is putting together a protein. So if you kind of think about it, that lots of different amino acids make up a protein that we eat. So all those Legos build that Star Wars ship, all those amino acids make a steak. Then a human eats that steak, and all of those things get broken down. So at my house, after the Star Wars ship is built, a couple of months later, it gets taken apart and something else is built from it. So if you think about it in that analogy, when you eat a steak or legumes or milk or anything with protein, your body breaks down all those amino acids and it reforms them into some different proteins. So the Star Wars ship would be the protein that you eat, and when you make a different ship from that, that would be the proteins that our body makes. Protein also is responsible for water balance, making hormones, transportation of different items in the bloodstream, and it can be used as an energy source. Not the ideal energy source, but it can be used. So what makes a protein different? It's this nitrogen right here. So every protein has this nitrogen group. Every protein has this acid group. So this is where this stands for amine. This stands for acid, amino acid. And then this part right here, this R group, this is what changes for the 20 different amino acids. So like I mentioned, there are 20 different amino acids, so 20 different building blocks. 11 of them are non-essential and 9 of them are essential. The essential amino acids must be consumed in the diet. And us as humans, we need about 10 to 35% of our calories from protein. When we learned about fat, we learned that we need anywhere from 20 to 35% of our calories coming from fat. You do not need to know the list of essential and non-essential amino acids. I just wanted to show those to you. You just need to know that there are some essential and some non-essential. Again, essential means that it must be consumed in the diet. So what are proteins? They're amino acids bonded together. Just like you put together a Lego piece by clicking it into the little holes, amino acids are bonded by peptide bonds. And we can make different proteins with those 20 essential amino acids. Another analogy would be words from an alphabet. There's 26 words, but we can make up millions, 26 letters in the alphabet, but we can make up millions of words. So where does protein in foods come from? The food groups in the My Plate, basically the protein group, the dairy group, the grains group, and the vegetable groups. As you can see, the protein groups, which are both plant and animal sources of protein like legumes and nuts and seeds, as well as chicken and fish and meat, those have the most protein. So about 7 grams per ounce, or about a quarter cup of nuts gives you about 7 grams. The dairy foods are quite high. You get about 8 to 10, even more for some yogurts in the dairy group. Grains have some, and vegetables have very little. The two forms of dietary protein are considered a high quality dietary protein, which is also called a complete protein, and those proteins are animal foods. And if you think about all the proteins in our body were built with essential amino acids and non-essential amino acids, so they have both in them. The same thing's true when we eat another animal. Those proteins have all the essential amino acids. However, the plant proteins do not contain all of the essential amino acids. Now, that doesn't mean that plant proteins are any worse. It just means that you have to combine those plant proteins to get all the essential amino acids. The problem in our body is that if you are making a protein and you are missing an essential amino acid, that whole protein synthesis stops. You can't build a protein without all the required pieces. And I'll give you another example of that in a minute. So animal proteins have all the essential amino acids, things like meat and dairy. Don't forget milk is an animal protein, a complete protein because it comes from an animal. Cheese, eggs. Unfortunately, animal proteins are high in saturated fat. Pardon me. They also have cholesterol because, as we learned from our lecture last week, anything with a liver contains cholesterol. Animal proteins make up about 70% of our protein. And unfortunately, that is one of the problems in our diet, is that we get too much of our protein from animal sources. Worldwide, only about 35% of most populations' protein comes from animals. So plant proteins comes from things like nuts and beans and grains. Like I said, vegetables have a little bit of protein, but they do not have a lot of protein. So thus, plant proteins are called incomplete because they do not contain all the essential amino acids, and they must be combined. So you need to put two of these together to get a complete protein. So if you have a peanut butter and jelly sandwich, the bread is a grain, and the peanuts, most people think of are nuts, but peanuts are technically legumes. So you're putting those two together, and thus you have a complete protein. So why are plant proteins so good for us? Because they don't have saturated fat, they have no cholesterol, they have more fiber, they have phytochemicals, remember those plant-based substances we learned about in chapter 1. And another problem with excess animal protein is our body tends to excrete quite a bit of calcium when we have to lose that extra nitrogen from the processing of excess protein. And with animal proteins, we tend to lose a lot of calcium with that. We tend to also have better glucose control. When you're eating things with fiber, that tends to slow that glucose response. So how is protein digested? Well, there's some mechanical digestion that occurs in the mouth when you chew a steak, and in actuality, you can actually think about cooking as the starting of the digestive process, because when you cook proteins, you notice you change the structure. So, for example, a raw egg turns white from the clear that it is before you cook it, and that's because you actually changed, or what we call denatured, those proteins into a form that is starting to be broken down so that our body can break those down easier. Stomach acid, hydrochloric acid, and then pepsin, which is a hormone in the stomach, continue to break those bonds, those peptide bonds, and then the pancreas releases more protein digesting enzymes like trypsin. So all those peptides bonds are broken, and the result is free amino acids that are absorbed in the small intestine. And after they're absorbed in the small intestine, they're transported to the liver through the portal vein. So then what happens? So this is probably the most important slide to think about here. In the liver, there's several options for these broken down amino acids. Okay, the first option is that they can be combined into the amino acid pool into the cells to form proteins the body needs. So that was that example I gave you. If you had the Star Wars ship and then you broke it down and built a different ship, the body can take all of those pieces and make those pieces into another protein. That is, if you have all the essential amino acids there. Okay. If perchance, when you have all those proteins in there, you do not need to build any proteins, or your body needs energy, then what happens is that nitrogen component, remember that amine group, that NH2, that is only used for amino acids. So if you need energy, you throw the nitrogen away and use the rest of the shell, which is carbons and hydrogens, to make glucose. You can also then store those extra carbons, hydrogens, and oxygens as fat. So when people think that a high protein diet is so beneficial because you can't store protein as fat, we don't store protein as protein. Our body has no storage form for protein. We cannot store nitrogen. So what happens is our body breaks down that protein and turns it into something that looks like carbohydrates and fats, and thus it can be stored. So protein storage, remember, we cannot store proteins for later use. Excess nitrogen is being excreted. First it's made into urea by the liver, and then it's excreted by the kidney. The other components, which is the hydrogens, the nitrogen, the hydrogens, the oxygens, and the carbons, are used for energy or stored as fat. So let's talk for another minute about essential and non-essential amino acids. And what I want to reinforce here is something called the limiting amino acid. Okay? And so here's an example. Let's say that our body needs to make this protein, supercalifragilisticexpialidocious. So that is the protein our body needs to make. So let's say that the amino acids are the letters. So that tells me I need 3 S's and 3 A's and 3 C's. So it's telling me all the amino acids or all the letters that I need to make for that. So then let's say I eat something that only has these amounts of amino acids. And I've highlighted the difference. So the food that I ate only has 4 I's, and the protein I want to make needs 7. So what happens? This is kind of a visual, and it doesn't really fit great on this screen, but it just shows you the body starts to make the protein. It plops the I's in, plops the I's in, plops them in, but then it gets to here and it says there's no more I's left. The thing to remember in this situation is that the protein synthesis stops. You don't make that protein. You can't store those amino acids for later. What happens, you store very few in the amino acid pool, but then that nitrogen gets thrown away and that carbon, hydrogen, and oxygen gets either made into energy if our body needs energy or stored as fat. So again, this is kind of a visual representation of the metabolism of the amino acids. So we've reviewed what the proteins do in our body. So how much protein do we need? This is another thing that I really want you to remember, that the RDA is the minimum amount of protein we need each day. This is the amount of protein we need, 0.8 grams for every kilo that we weigh, so that we do not get a deficiency in protein. It's not telling me this is the right amount, it's just telling me the minimum. For example, if you have a checking account and they say you have to have a minimum account balance of $100, it doesn't mean that you can't put $1,000 in there, it just means you have to have a minimum of 100. So here's an example. If you have a 154-pound person, they weigh 70 kilos, because to convert pounds to kilos, you divide it by 2.2. And that tells me that the minimum amount that 154-pound person needs is about 56 grams a day. So again, there's some changes that happen. If you're pregnant, if you're an athlete, you need more. But the minimum only represents about 8 to 10% of the calories we eat, and most of it eat more than that, and that's okay. What we want to do is keep that in balance to about 20 to 30% of our calories coming from protein. So how much is too much? If you get more than 35% of your calories, you're probably getting too much protein. Why is that bad? You probably aren't eating a lot of plant foods, which means you're probably not getting a lot of fiber, vitamins, and phytochemicals. And you're probably eating a diet high in saturated fat. You may burden the kidney, and you may increase calcium loss in the urine. What if we don't get enough protein? Protein malnutrition can occur. The two different types are marasmus and kwashiorkor. And then the last part of this slide that I'll go through very quickly is talking about vegetarian diets, the different types of diets, and the healthful principles of the vegetarian diets. Most of the time, vegetarians can get more than adequate protein in their diet, even if they're vegans, which means they avoid all animal products. Sometimes there are certain nutrients like calcium, iron, and B12 that become a concern. But again, remember, you can combine these proteins. And yes, a vegetarian diet is very healthy. All right, that's all.